So think about the world you see and feel right now, the messy, changing, vibrant world, colors, sounds, solid things.
Yeah, the world of immediate experience.
Now contrast that with the world physics talks about. Points, instants, these abstract equations, particles you can't even see.
It's a totally different picture, isn't it?
Right.
Precise, mathematical.
How do these two possibly connect? What's the bridge, between what we sense directly and this abstract reality science describes?
That's the big question. It feels like two different languages almost. One subjective, personal. The other aims for this objective structure, universal laws.
Finding a way to translate between them, that's a huge philosophical task.
A really fundamental one.
And that quest is exactly what our sources here are tackling head on. We've got this material that really digs into this relationship.
Right. One source calls it the link between the crude data of sense and the space, time, and matter of mathematical physics. That sums it up pretty well.
So our mission here in this deep dive is to unpack what these sources say. Use them as a guide, really.
Exactly. See how they propose building our understanding of the physical world, starting right from the bottom, our most basic subjective sense experiences.
Okay, let's dig in then. Now, these sources, they don't just jump into their own solution, do they? They kind of set the scene first.
Right. They look at some older philosophical approaches, they think. Well, fell short.
What kind of approaches?
They talk about the classical tradition, often quite idealistic, the idea that reality is fundamentally spiritual or mental, maybe some kind of ultimate absolute.
And they use logic, but maybe differently.
Yeah, sometimes to argue that the world we actually experience, the world of separate things and how they relate, is somehow contradictory or not the real reality.
Like that example from Bradley, arguing that relations themselves just don't make logical sense. That sounds really counterintuitive.
It does, because relations are everywhere. But the argument as presented was something like, well, if A is related to B, you need something to connect A to the relation and the relation to B, and doesn't that just go on forever?
An infinite regress. Okay, so that casts doubt on the reality of the world as we know it.
That was the idea, yeah, to question the everyday world of distinct objects and connections.
And there was another viewpoint they pushed back against too, something about evolutionism.
Yes, or vitalism.
Yeah.
Thinkers like Bergson are mentioned. This view really emphasized intuition.
Intuition over intellect.
Pretty much. Intuition was seen as the way to grasp reality directly, especially fluid things like change, life itself. Intellect, on the other hand, was seen as more rigid, static, only good for practical stuff, dealing with fixed things in space.
I remember the examples they used, like intuition in animals or kids.
Or comparing, say, a savage versus a civilized person's way of understanding. Vivid examples, for sure.
But the sources aren't buying intuition as the best tool for philosophy.
Not entirely. They acknowledge it's useful for survival, that gut feeling, quick pattern recognition. But for careful philosophy, they argue it's less reliable. It's based on habit, maybe instinct. It's not rigorous enough when you need to really dissect complex ideas carefully.
So intellect, even if some saw it as limited, is actually the better tool for building solid philosophical knowledge.
That's the argument presented, yes.
Yeah.
You need that analytical power.
Okay. So out of this critique of older ways, what emerges? What's the new approach?
It's described as adopting a scientific attitude in philosophy.
A scientific attitude. What does that mean in practice?
Well, it means shifting the goalposts a bit. Moving away from philosophy as primarily a source of comfort, or finding some grand moral purpose in the universe.
Less about finding meaning, more about finding facts.
Kind of. The focus becomes precise fact-finding, really rigorous analysis, and accepting conclusions based on evidence and logic, even if those conclusions aren't comforting or if they mess up your neat philosophical system.
Right. Less system building for its own sake.
Exactly.
And if philosophy is going to be more scientific, it needs data, right? Like any science. Where does it get its data?
Good question. The sources say it starts with common knowledge. Just the huge amount of stuff we generally accept about the world and everyday life.
But surely not all common knowledge is equally solid.
No, absolutely not. And that leads to a really important distinction they make between hard and soft data.
Hard versus soft.
Yeah. The hardest data is your own immediate sense experience right now. The fact that you seem to be seeing a particular shape or hearing a sound, whatever the cause, the experience itself is incredibly hard to doubt.
So the raw sensation, that's the bedrock.
That immediate awareness, yes. Then soft data is, well, pretty much everything else.
Like what?
What other people tell you, history books, geography, even the results of physics experiments, you rely on this stuff constantly, obviously.
Yeah.
But it's all built on layers of inference, testimony, trust. It's less certain than that immediate flicker of sensation.
But the idea isn't just to doubt everything, is it? Universal skepticism.
No, they see that as practically barren. Doesn't really get you anywhere. The method is more like take common knowledge as your starting point, warts and all, then use careful examination, logical tools to sift through it, refine it, check for consistency, clean it up from the inside rather than trying to stand outside it and doubt everything.
Okay, so you use logic to refine common knowledge. And this brings us to something you mentioned was revolutionary, modern logic.
Yes, this is absolutely crucial for their whole project. They point to the work of people like Cantor, Frege, Peano, Whitehead, Wittgenstein.
Big names in logic and mathematics.
Huge. And the claim is that modern mathematical logic wasn't just a small step forward, it was an internal revolution in thought. It gave thought wings, freed it from old limitations.
What were those limitations? What couldn't the older traditional logic do well?
It was very focused on subject-predicate propositions. Socrates is mortal, the cat is on the mat, statements assigning a property to a single subject. But that structure really struggled or even distorted things when you tried to express relations between things.
Like London is north of Paris or Alice is taller than Bob.
Exactly, those kinds of things. Traditional logic had a hard time analyzing the structure of those statements properly. Modern logic gives you the tools to handle relations rigorously. It lets you talk about different types of relations, transitive, like greater than, symmetrical, like is married to, asymmetrical, like is the parent of.
That ability to handle complexity beyond just subject-predicate must have opened things up.
Transformative, yeah. It allows for a much richer, more accurate representation of how things connect.
And this new logic also helps clarify how facts and knowledge are structured.
Definitely. It shows a fact isn't simple. It has parts, things, their qualities, the relations between them. We can talk about atomic propositions for simple facts, combine them into molecular ones using and or if, the blend, and make general statements using all or some.
And there's a really key insight here that challenges pure empiricism, right? About general truths.
Yes, exactly. Logic itself reveals that we seem to know certain general truths, like basic logical principles, the law of non-contradiction, for instance, that we don't learn just from sense experience.
You don't go around testing, if P is true, then it's not the case that P is false.
Right. You don't need experiments for that.
Yeah.
These principles seem to be known in a different way, independently of specific experiences. And having some non-empirical knowledge is vital if you're trying to build a foundation for science, which relies on universal laws.
Okay, so we have this powerful new logical toolbox. How did the sources use it to tackle that original problem, bridging the gap between subjective sense data and the objective world of physics?
This is where we get to what's probably the most radical idea. Logical construction.
Logical construction.
Yeah. Instead of assuming that physical objects or points in space or instants in time are some kind of separate reality hiding behind our sense data.
The thing in itself, maybe.
Sort of, yeah. Instead of assuming that, they suggest we should define these physical concepts, construct them logically out of the sense data itself.
Hold on. So a physical object, like this table, isn't some hidden substance. It's defined as a pattern of experiences.
Essentially, yes. A specific organization or pattern of actual and possible sense experiences.
Okay, wow. How does that work? Our experiences are so personal, private even.
Right. They start with the idea of private worlds or perspectives. What one person sees, hears, feels from their unique viewpoint at a particular moment. That's the raw material.
Your sense data right now is your private world.
Exactly. The challenge, then, is to find systematic ways to correlate these different private perspectives, to build shared concepts out of them, like a common perspective space that organizes all these viewpoints.
How do you get a single stable thing, like the table, when its appearance changes constantly? As I move, the shape, the color, everything shifts.
That's the beauty of the construction. The table isn't identified with any single appearance. It's defined as a system or grouping of all its correlated appearances across different perspectives, actual and possible.
Correlated how?
Correlated according to certain laws, primarily the laws of physics. Think about walking around the table, like the source example. You experience a smooth, continuous series of different visual appearances, different shapes, sizes, angles. And these visual changes are correlated with your own feelings of movement, the changing perspective. Common sense, and physics more formally, interprets this consistent pattern of correlated appearances, obeying predictable laws, as evidence for a single, persistent physical object.
So the object is the pattern, not something underlying the pattern.
In this view, yes. It's defined by the structure of its appearances across all possible viewpoints, governed by physical laws. You don't need to assume some mysterious, unchanging substance behind it all. The consistency of the appearances is the objecthood.
Okay. What about the really abstract stuff physics uses? Points in space, instants in time. We definitely don't experience dimensionless points or durationless instants.
Right, they aren't given an experience at all.
Hmm.
And the argument is these are also logical constructions.
Constructed from what?
From the actual data, which is events with duration and things with spatial extension. An instant, for example, isn't something you can isolate and experience. It's defined logically as, say, a class of events that are all simultaneous with each other.
So you take all events happening now across different places.
And you group them together using the relation of simultaneity. That whole class is the instant. It's an abstract structure built using relations like earlier than, simultaneous with, wholly precedes, applied to the events we do experience.
It's a way to impose a precise mathematical structure onto the flow of experience.
Exactly. And correlating time between different observers gets complicated, of course. If we hear thunder, it reaches you slightly before someone further away.
Different private times.
Yeah. But physics gives us the laws, like the speed of sound or light, to logically correlate these different private time orderings back into a single public time framework. Again, it's a construction based on observed regularities and logical relations.
What about other people? We assume they have minds, feelings, like us, but all we actually sense is their bodies, their actions, the sounds they make.
That's treated as an inference, basically an argument from analogy.
Because they act like I do in similar situations.
Pretty much. You see someone stub their toe and yell it. It looks very similar to how you react when you stub your toe and feel pain.
Mm-hmm.
So you infer they're probably feeling pain too.
Is that inference justified, according to the sources?
They suggest it's justified by its overall coherence and consistency with everything else we experience. The patterns of behavior we see in others in waking life are vastly more consistent and predictable than, say, the characters in our dreams. That regularity supports the analogy.
Okay, so the really big idea here is using logic not just to analyze, but to actively construct the concepts of the physical world, objects, space-time, directly from the patterns and correlations found within our subjective sense data.
Yes, it's a way to show, rigorously, how the objective, seemingly independent world described by physics doesn't have to be seen as separate from our subjective experience. It can be understood as being built out of that experience using these powerful logical methods.
It's quite a shift in perspective. And this analytical approach, this focus on logic and construction, also helps with some really old, knotty philosophical problems, doesn't it? Like infinity and continuity, Zeno's paradoxes.
Zeno, yes. His paradoxes are classics for a reason.
Like the race course. To finish the race, you have to get halfway first, but then you have to get halfway through the remaining half.
And halfway again and again. It seems like you have to complete an infinite number of steps just to get started.
Or Achilles and the tortoise. The faster runner can never catch the slower one if the tortoise gets a head start.
Because every time Achilles reaches where the tortoise was, the tortoise has moved a little bit further ahead. It seems impossible.
These paradoxes really messed with people's ideas about space, time, and motion, right? Especially if you thought space and time were made of tiny indivisible points or instants lined up one after another.
Exactly. If there's always another point between any 2 points, how do you ever get from one point to the next one? It seems motion should be impossible.
So how does the modern logical approach resolve this?
The sources point to the positive theory of infinity, which came out of George Cantor's work on set theory. This basically showed that infinite sets are mathematically and logically coherent. They just behave differently from finite sets.
Infinity isn't inherently contradictory.
Right, and combined with that is a clear understanding of mathematical continuity.
What's key about continuity here?
It's the idea of a compact or dense series, like the rational numbers, the fractions. Between any 2 fractions, say 12 and 34, you could always find another fraction, like 58. There's no next fraction immediately after 12. If you model space and time as continuous in this mathematical sense, then motion isn't about jumping from one point to the next discrete point. It's a smooth transition through a dense series. The paradoxes dissolve because they were based on faulty assumptions about how infinity and continuity work, assumptions cleared up by modern mathematics and logic.
Wow. So a clearer definition solves the ancient riddle. And speaking of definitions, even the concept of number itself got a logical makeover that's relevant here.
Absolutely crucial, yes. This was largely pioneered by Frege. Before him, people thought of number as maybe a property of things, or perhaps just a psychological idea in our heads.
But Frege showed it was something else.
He showed it's fundamentally a property of classes or collections of things. Not of the things themselves, but of the collection.
How does that work?
The rigorous definition is something like this. The number of a class, say the number of apples in this bowl, is defined as the class of all classes that could be put into a perfect 1-1 correspondence with it,
Whoa, okay. The class of all classes.
that are similar in quantity. So the number 3 isn't just in these 3 apples. It's the abstract property shared by this collection of apples, that collection of chairs, any collection that you can match up 1-to-1. It's the class of all trios.
That's very abstract, but powerful.
Incredibly powerful, because this logical definition works just as well for infinite classes as for finite ones.
Ah, linking back to infinity.
Exactly. It provides a rigorous way to handle infinite numbers and showed definitively that infinite sets can have the same number of members as a proper part of themselves. Like there are just as many even numbers as there are whole numbers, even though the evens are only part of the wholes.
Which defied old intuitions.
Yeah.
Right, even Leibniz apparently thought that was impossible.
It did. It overturned centuries of thinking based on finite examples. Logic provided the key.
Okay, shifting gears a little bit, let's talk about causation, cause and effect. It feels so fundamental to how we understand the world. Where does that belief come from, according to these sources?
Well, it starts with just observing regularities, uniformities in our experience.
Like lightning, then thunder.
Exactly. Or flicking a switch, then the light comes on. Or even expectations in animals, a horse knowing a familiar road. We see these sequences happen over and over.
But David Hume had something important to say about this, didn't he?
He did. Hume's great insight, which the sources discuss, was to show that while these repeated observations lead to a very strong psychological habit, we expect the thunder after the lightning. They don't give us a strict logical reason to believe the sequence must happen next time, or that it always happened in the unobserved past.
So it's a powerful habit of mind, maybe an animal belief, but not a logically necessary truth.
That's Hume's point, yeah. And the sources seem to largely accept that. Cause and effect is incredibly useful, vital for science and daily life. But its ultimate justification rests on an assumption, the uniformity of nature, which can't itself be proven logically just from experience.
And some thinkers, Bergson was mentioned again, they challenged universal causation differently, didn't they? By arguing every event is unique.
Right. The idea was, especially for mental events, that each moment includes its entire history, making it absolutely unique. So how can you have a causal law if the exact same event can never ever be repeated?
How do the sources respond to that?
The response within this analytical framework is that causal laws don't actually require identical repetitions. They relate kinds or types of events.
Ah, okay. Not this specific spark causing this specific fire, but
But the type of event spark in proximity to dry tinder is causally related to the type of event fire. The law friction causes heat connects the category friction to the category heat. You can predict, say, that reading the same poem over and over will probably lead to boredom.
even though each reading is slightly different, incorporates the memory of the last one.
Exactly. The prediction works because readings of that kind tend to relate causally to feelings of that kind, boredom, under those conditions. The law abstracts away from the unique details to relate general categories.
Okay. This seems to lead naturally to that huge perennial question, free will. If our actions, our choices, our events, are they also subject to causation? Are they determined?
The sources approach this largely as an empirical question, something to be investigated scientifically through psychology, maybe neuroscience, physics.
And what does the empirical evidence suggest as they see it?
Well, empirically, it certainly looks like our volitions, our acts of will, our choices are caused, typically by our desires, our beliefs, our character, the circumstances we're in.
But wait, if my action is caused, maybe even predictable in principle, doesn't that mean I'm not free? If someone could foresee what I'm going to do, how can I be free?
This is where they argue for careful analysis. The idea that foreknowledge destroys freedom is seen as a confusion.
No.
Foreknowledge doesn't compel the event. Think about memory. Remember what you did yesterday doesn't compel you to have done it. Similarly, if someone could foresee your action, their foresight would have to take into account the entire causal chain leading to it, including your own desires and deliberation as crucial parts of that chain.
So the foresight would be true because of how I'll freely choose based on my desires.
Exactly. It doesn't force the choice. So, freedom, in the sense that actually matters, isn't about acting without any cause. It's about acting from your own internal states, your own desires, values, reasons. Your actions spring from who you are.
So freedom is compatible with causation as long as the cause is internal, coming from my own will and desires.
That's the argument presented, yes. That's the valuable kind of freedom. The desire for some other kind of freedom, maybe completely uncaused cause kind of freedom, is seen as based on, well, insufficient analysis, a misunderstanding of what freedom worth having really means.
Okay, so stepping back now from all these specific topics, logic, construction, causation, free will, what's the big picture? What does this whole journey tell us about the method of philosophy itself as these sources present it?
Fundamentally, it's a method of analysis and construction, critical analysis and logical construction.
Break that down a bit.
You start with the data you have, which is often complex, maybe vague or ordinary common sense ideas about things, space, time, mind, cause, and so on.
The messy stuff.
The messy stuff, exactly. Then you use the sharpest tools you have, which for them is modern logic, to analyze this data, to break it down into simpler, more fundamental, maybe more abstract components, constituents, relations.
Okay, analysis first.
Then you use logic to carefully reconstruct more precise concepts from these simpler components. You build definitions, logical constructions that aim to capture the essential structure of the original data, but in a much clearer, more rigorous, scientifically respectable way, like defining an instant as a class of simultaneous events.
So analyze the vague into the simple, then logically construct the precise from the simple.
That's a good summary, yeah. Break it down, then build it back up more clearly.
And what's the hope for philosophy using this method? What's the prospect?
The prospect is making genuine progress, solving problems, or at least clarifying them immensely, where those problems are amenable to this kind of logical analysis, like Zeno's paradoxes or the nature of number. Incremental progress, like in science.
But maybe not all traditional philosophical questions fit this mold.
Possibly not. The sources seem to acknowledge that questions driven more by, say, a search for ultimate meaning or ethical certainty or spiritual comfort might fall outside the scope of this strictly scientific logical method.
And there's a warning that comes with this method too, isn't there, about getting too attached to your system.
A very strong warning against the love of system or the system maker's vanity.
Don't fall in love with your own beautiful theory.
Right. Don't try to force reality into your neat logical structure if it doesn't fit. The method has to serve the data, not the other way around.
They use Pythagoras as an example.
Yeah, a great historical example. Pythagoras had this amazing, powerful system built on the idea that everything in the cosmos could be explained by ratios of whole numbers. Music, astronomy, everything.
A beautiful system.
Hugely influential. But then came the discovery of incommensurables, things like the square root of 2, the diagonal of a unit square. It cannot be expressed as a ratio of two whole numbers. It's irrational.
And that didn't fit the Pythagorean system at all.
Not one bit. It was a crisis. And the point is, that single awkward, inconvenient fact, the irrationality of Chateau, turned out to be vastly more important for the future of mathematics than Pythagoras' entire elegant system. You have to be willing to accept the awkward facts, the things that break your system, because that's often where the real progress lies.
A crucial lesson in intellectual honesty. So, reflecting on this whole deep dive into these sources, we started with that puzzle. Messy sense experience versus abstract physics.
How to connect the world we feel with the world science describes.
And we saw how this revolution in logic provided really powerful tools. Tools to analyze reality beyond simple subject-predicate stuff. Understand facts, propositions.
And crucially, tools to construct the concepts of physics things. Space, time, points, instants. Not as hidden realities, but as complex, logical patterns built from our sense data, correlated across different perspectives.
We saw this analytical method dissolving ancient problems like Zeno's paradoxes, giving rigorous definitions for things like number and continuity.
Yeah, showing how logical clarity could untangle centuries-old knots.
And then we looked at causation, seeing it based on observed regularities, but maybe not logically necessary in free will, framing it as compatible with our actions being caused by our own desires.
And throughout, the consistent theme was this scientific analytical approach. Start with the data of common knowledge, use logic to analyze and purify it, and then use logical construction to build precise concepts that account for that data.
It's been a really fascinating look at how breaking things down, analyzing carefully, using logical definitions, how that can bridge what feels like a huge gap between our intuition and scientific abstraction.
It really highlights the power of that method.
Yeah.
Taking concepts we think we understand intuitively, like thing or time or number, and showing how much deeper insight you gain when you subject them to rigorous logical scrutiny.
Okay, so here's something to leave you with, a final thought building on all this. If we take seriously this core idea from the sources that the physical world, the objective world out there, is best understood not as something totally separate, but as a complex logical construction built ultimately from the subjective data of our senses.
A radical idea, but central to their argument.
Does that change how you think about reality itself? About its ultimate nature? Or maybe about the limits of what we can truly know, independent of how we experience and structure things? And maybe think about other concepts that seem solid and objective in your own life or work, maybe ideas like justice or economic value or even personal identity. Could they also yield surprising insights if subjected to a similar kind of careful logical analysis, breaking them down and seeing how they're constructed from more basic elements? What might we discover then?